This is project 1.2, Analog Oscillator. Here's the completed build. I'll be showing how to build this circuit and how it works. The prototype looks like this. The prototype has 5 different components: 1 9-volt power source, 2 2N3904 NPN transistors, 2 1K ohm fixed resistors, 2 10K ohm fixed resistors, 2 100 microfarad capacitors, and 2 yellow LEDs. To build it, follow the schematic, and when done, it should look similar to this. Any misplacements in the wiring will cause the circuit not to work, so a lot of troubleshooting may be necessary. Now transitioning from prototype to permanence, the PCB. The PCB serves as a permanent and improved form of the prototype from a functional perspective and is all tied together within an encasement. For the PCB and encasement, I used 3 2.54mm terminal blocks, 1 single-pole double-throw slide switch, 1 PCB, 1 48220 Schroeder jacks, 1 5mm kinked power jack, 4 black Phillips screws, and 1 3D printed encasement. After soldering all the components into their respective places, the completed build would look like this. So how does this circuit work? The functionality of the analog oscillator heavily depends on the interaction between 2 transistors and capacitors. In this analog oscillator, as one capacitor charges, the first transistor turns on, causing the LED connected to it to light up. Simultaneously, the second capacitor discharges, turning off the transistor, causing the LED to go off. This continuous cycle results in an alternating on-off states for the LEDs, producing a flashing effect controlled by the timing components in this circuit. Such a continuous back and forth is ensured by the positive feedback loop so that one capacitor is able to charge at the same time when the other is discharging. Taking a look at the completed build and the Fallstat animations, we can see this in action. Oscillations characterized by a square wave output are controlled by a time constant, tau. The time constant is the product of the resistance and the capacitance, tau equals R times C. The time constant calculation decides the pace of charging and discharging, forms a unique pulse, and fixes the entire frequency of the analog oscillator's oscillation. In conclusion, the analog oscillator contains a thorough explanation of the construction and understanding of an analog oscillator circuit. The delicate interplay of these factors, controlled by the positive feedback loop and calculated time constant, illustrates the fine balance necessary for achieving the appropriate frequency response on the circuit. This is Project 1.2 Analog Oscillator. Thank you for watching.